Central angles of a circle. Are you done? Pretty close. Are you getting closer?
Well, I'm just doing the quizzes.
Okay. All right. So in order to do that, I'm gonna show some boxes to you with the book, and then we'll go on from there. So the first box of the day is called the sum of central angles. And I'm going to try to get it here where we can read it if you can. Remember the book? I'll hold it like this. And there you go. Okay. So the sum of central angles, if you can't see it, get over here somewhere where you can. In fact, just stay there. We're going to be doing a lot of work today. A lot of things to write down. And yeah. What the name of it is? Sum of central angles, right there, this one. Or just central angles. Daxton.
Are you serious? Is that a kidney weighs 4 pounds?
Well, no, mine was like
Oh, it's fine. Best weight solution here.
You have an ulcer?
Yeah.
Old people get ulcers, dude. That's like my age.
Well,
That means you...
he aged like 10 years when he was 10.
Sam's really 26 right now.
I have a knee problem too.
Oh,
Basically, like,
Judas Priest, you're like a 40-year-old right now, Sam. You know, he sounds like me. It's ulcers, knee issues. The minute you start getting random headaches, talk to me. And then you're me. Then you're basically me.
What's an ulcer? So you want me to go
Bleeding in your intestine when you get a little... Why is that funny?
I don't know. Just the way he said it, and then he laughed.
Intestine. Yeah, will you go do that?
Okay.
Cut them up for me.
Some words are just funny.
Count them up? I have to count them?
No, I didn't mean cut them up.
Oh, I was like, count them? I can't count that.
Just go get like 2 of them, 2 packages, and cut them in half. They don't have to be close. They can be, just get them as close as you can.
You ever just want to get hurt, so then like, you have a reason not to do anything?
Okay.
Right now, instead of just not doing anything anyway.
All right. So listen. This is a central angle. So I'm going to bounce back and forth. Shush. I'm not going to keep talking over everyone. Sam, I mean shut up. Okay. I'm not going to keep talking over everyone, so everyone be quiet. We got a lot to get through today. It's going to take a lot of the hour. So, central angle. Central angles are angles that start with a vertex is in the center of the circle. That's why they're called central angles. Now, this theorem right here says if you add up all the central angles of a circle, they're going to add up to be 360 degrees. Why? Because technically that makes a circle right there in the middle, and we know circles to be 360 degrees. So no matter adding up these central angles like this, we know that they're going to add up to be 360. So what I wanted to do is I wanted to show you a couple of examples in the book here without me having to create them. It might make the day go by a little bit quicker. So if we look at these, ignore the top one. Look down here. I know it gives you the answer, but we're going to figure out how the answer is 50. Well, we know that this angle right here is 145, and this angle right here is 165. To be able to get what x would be, we just go add it together, subtract from 360, get x. Over here, we have an 85, a 40, a right angle. We can add those 3 together, subtract from 180 to get x again. Okay? So that's how Well, I told you to move closer if you needed to. See it? Okay? So,
I can, when did I say anything about not seeing
I
it?
thought you said I couldn't see it.
Okay, thank you.
So, same thing. No, I just wanted you guys to write down my box. Okay, any questions right now about central angles? Now, these central angles will have names attached to them. And what I mean is they'll have a middle of the circle. So, for example, if I have, like this right here, if we just look at this circle right there, this central angle would be RQP, or PQR, right? So that angle right there has a name right there. It's from the edge to the center to the edge, and that would be the name of that central angle. So for example, if we go up here to this central angle, that one right there would be ABC or CBA, right? Any questions on that, how to name them or anything like that? Okay, we're going to go into the next part. This is a bigger box. It's a big one. I'm going to give you quite a while to be able to work on it. Probably 10 minutes.
Holy
Go for it. We're going to get all the information down, then we'll start doing the math that associates with it.
Yeah, that was awesome.
This one's arcs and arc measures. So now we're going to talk about arcs. Every circle has arcs. The circle is divided into arcs. And this is the beginning of the talk of arcs. Shut up, Cole. This would be such a boring day to watch. Can you imagine watching the recording? It'd be like fast forwarding, stopping, fast forwarding, stopping. I should just randomly say math terms so those people that are watching online are like, oh, he's actually talking about crap and I'm not even talking. It's just you guys copying stuff. Like if you take the derivative of the second function, you will get the antiderivative of the first function.
Unfortunately, now they all know your game plan.
Yeah.
Dang it, dude. That's So they won't even hear it at all. So they won't even. Okay.
Everything.
Yeah.
Who's done with like the first couple? Can we about 2 or 3 more minutes?
I just got done with the first one. Me too. Just
I'm almost done with the first.
All right, I'll give you that 5, 6 minutes.
Don't you hate how Jace goes in those ones? Like, that's so weird.
Lumpy? Lumpy. Lumpy's word. Feels right.
That's what I was all the king's horses and all the king's
You do. All right, Tyson, let's go. Just to let you guys know, my plan kind of is good. We're going to cover central angles. It's going to take a little while, and then I want to pull up and kind of what it looks like on your homework, because it does look a little different on your homework than forward. And then we're going to talk about arc length too. Good enough for me. That'll last for a week, maybe a few days.
You use a lot of paper.
Lots.
You use the most.
It'll,
Chemical.
You better be recycling.
Is that all you need from me
You're gonna get Mr. Walker mad.
that's good. Yeah, thanks, Cole.
I have to go do a job there. For
What?
the box.
You do?
Yeah.
Good luck.
Isn't he in construction?
Who is it?
Brother Cox, that, on our ward.
Something. Are you going to drive him clear out there to his house? Oof. That's a long way out there.
Oh, not out there, but
Oh.
close up to down there.
Oh, I don't know.
Haul it off, bro.
We've already talked about this. How? Well, you're about 6 months behind everyone else, man. We've already talked about this 20 minutes ago.
want to go fly fishing.
what I would do to be fly fishing right now instead of.
Dude, fly fishing is, I love
You know
it.
the animals?
No, I don't fly fish, but I'm saying what I would do to go fly fishing. I don't have friends that are willing to teach. No one's
taught
willing to
myself.
teach. I want somebody that knows what they're doing, like
I
Buck
literally
York
taught
to teach me.
myself, you're good. I promise you.
I can, I know how to.
No, you
It's
don't.
not difficult.
No, you don't.
You literally go,
You don't even know.
I do know. I know everything.
no, you
You
don't.
don't.
You're stupid. But not really. But, like, you're stupid in the smart way.
You're you're the dumbest stupid person, or smart person I've ever seen.
Yeah, says. He said dumbest, stupidest person.
And you went. So I think we're even right now.
Did everyone already say you were fishing?
Yeah.
Oh, I don't think I was there.
Yeah, you were. You were sitting right there.
He was late.
Was he?
So,
I was late, yeah.
he's so. But it is a nice shirt. I do like this outfit.
Mr. Glacier, know what you do need to do. Not same fit, but
You don't have like a booty.
Hey, are we done? Are we talking? We're done then, right?
no.
Okay, you guys got about a minute and then we're going.
Oh, no.
I'm actually not, I got that for sure.
You got a minute and then we're going.
Did you get a new one? Why does it have a blue line?
No, it's had the blue light.
Well, it's going in a different direction.
No.
Yeah, okay.
How does it?
It's a new one. I just think one of them had like a like, how was that? It had like a projecting like that. Wouldn't it distort it? And make that one on the bottom?
It was straight on then.
Okay.
Wait.
All right, so a minor arc, right? So we're going to start off right there. Well, first off, every central angle makes an arc. So let's put over hand right there. A central angle makes an arc. Now, what the size of that arc is depends on the size of the central angle. But before we get to the measures and stuff like that, we need to talk about these things. A minor arc is an arc that is less than 180 degrees. So a minor arc is an arc that's less than 180. Any arc that's less than 180 is considered a minor arc. A major arc is any arc that's greater than 180 degrees. And a semicircle arc is any arc that is 180 degrees even. Now, look how they write arc. I hope you guys registered that when you're writing this. You write it with a little curved line above it. That means arc. So look at this real quick. I want you guys to focus on this. Angle ACB equals arc AB. So the measure of the central angle equals the arc that it makes. So does everyone see how angle ACB makes arc AB right here? Whatever this central angle is right here would be the exact same thing as this arc. So if this central angle was 110, the arc would be 110. Okay? So if we look down here, so this is talking about arc ADB. So it's this entire outside of the arc out here. If we're told that this is 287, if this angle right here, which is kind of this backwards, if you think about it, this part of it, which is really hard to start thinking, right? Because this angle, I'm going to draw on my book and pen right now, but this angle isn't this, it's this. We're talking about this angle right there, right? So it's greater than 180. So we know that this could be, so if this angle right here is 220, that arc would be 220. Okay? And of course, if this is a straight line, we know that this angle right here would be 180, which means this whole thing is 180. Okay? So if we look down here at these examples, it says that GJ is the diameter. So we know that GJ is a diameter. So let me ask you guys a couple things here. If GJ is a diameter, can we find this angle right here?
Yep.
How?
Minus 622.
So we know that's going to be 58, right? So we know that's going to be 58. So then it says find the measure of arc GH first. What's the measure of arc GH? 122. If this is 122, if the measure of this angle is 122, the measure of that arc is 122. And then it says find GLH. So from here, we read it the exact same way it says. GL, so this entire arc all the way up to right there. GLH is that entire arc. So what would be the measure of that entire arc? 238, right? The reason being, well, Andy, tell us why it's 238.
Because G, J1 is 180, and just write in H, it's just
Good. So GLJ is 180, because it's a semicircle, plus the additional 58 would make 238. Okay? So we just, all you have to know is that central angles, the measure of the central angle equals the measure of the arc. Okay? Look at this example right here with me. Here, I'll try to zoom in a little bit if I can. I don't think we need to look at the words. We can zoom all the way into this puppy. Come on. Nice. Okay. So the first one says MQ. Raise your hand if you could tell me what the measure of the arc MQ is. So we're talking about that. How can we find that?
90 minus 15.
180 minus 115. Good, Ethan. How do you know that?
Yeah,
Because
because it's a right angle.
is a diameter.
Yep. PM's the diameter, so we know that this is 180. So if this is 115, this has got to be 65, which means the measure of this arc is 65. Okay, the next one is MNP. So from here to here to here, it'd be 180. Why? Because it's a semicircle. The diameter cuts it in half, right? If there's 360 degrees, half it's 180. Okay, what about this one? MNQ. And we follow it the exact same way it's written. One of the most common mistakes I see people do is, so it's saying MNQ, which is this arc from M all the way around to Q. I see a lot of people, they see MNQ like this. And what they do is they go, well, MN to Q. And they just think it's that. It's not.
That's what I was thinking.
Yeah, because that's what a lot of people make the mistake, but we read it the exact same. As we're going around the circle, we go from M to N to Q. Does everyone see that? We can't go N to N and then back to N over Q. Well, okay. So, and that one gives you the answer. The way you know it is we're going to go 180 plus 115. So the measure of the central angle equals the measure of the arc. Whatever it is, okay? So whatever the central angle is equals the measure of the arc. Okay, here we go. Next box. There's a couple more. There you go. Go for it. We got one more box after this one.
Oh, wait.
Whatever. Just, you can even title it Theorem 11.1. That's what it says to title it, so I would just tell you the same thing. This is the first theorem of chapter 11, and it is the first of many coming. What are theorems again? Who can tell me?
Dr. V.
Yeah, theories that have been proven true 1,000 times over in math. So no matter what, this is 100% truth right here.
Ever think about this? Just
That
someone
sounds
just made up
pretty
it, you know.
Can't. It's been something that's been proven true. That's how they're theorems.
What if somebody proves it? Well,
Then it wouldn't be a theorem anymore, but it's you can't.
how do you know?
Well, I could just make up something else.
Are you like
Now,
telling
straight up.
me?
What's your name? It's not. Stop lying.
Kevin.
No, it's
Kevin. Doesn't he just look at it and tell me it doesn't look like Kevin? Like the whole nose thing? You look like a Kevin. Not the thing. Not even the thing.
Teddy, here, I'll tell you.
You know the kids on hand, the guy from Saw?
Kevin.
What?
He looks weird. Have you seen a picture of him in the
Sam, right.
No, the Home Alone guy is
Grown up now.
The Home Alone kid.
Yeah, you like freaking practice.
You look like it.
Alright.
Tyson, right.
Why is it always me?
Well, because you kind of started.
That's
What does cap mean?
Kevin.
False.
It's like,
What does cap mean?
Like you're
False.
lying.
Not true.
False. I mean, he's getting older.
Cap?
Stop capping.
Stop
That's
cap.
what they say.
Stop cap.
Well, capping is like when people shoot people.
Hey!
That's what I said. I actually thought that when people have been saying that recently, I'm like,
That's Papa Cap. Okay, cap and Papa Cap. Like
There's a
my brother,
big
Papa
difference.
Cap.
they're the exact same word.
No.
No, one's a phrase, one's a word.
Couldn't be like you capping. Couldn't be like
No,
the guy's wearing a hat. Like, hey Jackson, you capping.
No.
No, cap.
first of all, that's,
He's got a cap on.
No, it's the, how you use it in the phrase.
Yeah, you capping, man.
Yeah, like deer. No. You just said it's.
Or like, they have 3 different theirs,
Yeah,
okay?
you're
That's
capping
crazy.
line. Capping.
No, what happened is some famous dude said it on accident,
No.
and they're like, somebody in an interview is like, what does that mean? He's like, oh, it means they're lying.
Yeah.
And then everyone else is like, oh, that's sweet.
That's bad.
We're gonna change the whole English language, except for then it's like, that's sick. Same reason why sick is like cool, you know, that's sick. Somebody was really sick and they're like, oh, you're sick? I'm not, I don't feel good, I don't feel cool. Oh, that's sick, dude, that's sick. And then somebody took it the other, it's just English language, you guys, we're jacked up human beings. Okay. Alright, this is extremely self-explanatory. In the same circle or in congruent circles, 2 minor arcs are congruent if and only if their central angles are congruent. So what that means is, if you have minor arcs that are congruent, their central angles are congruent, no matter what, right? Because if you have a central angle if you have an arc that's 30 and another arc that's 30, the measure of their central angles have to be 30, no matter what, right? Because the central angle always matches the arc, no matter what. Okay, onward. I gotta go. We gotta go. We're not gonna have more time. Just copy someone else's. Here, we're going to this one. This is the one that was most important right here. I see a lot of people get these 2 things screwed up. So now we're done with arc measure, and now we're on to arc length. They are different.
I know I'm just not going to get this after this thing.
X over 3 is the formula x over 360 times 2 pi r.
Yeah.
L is length.
Yeah.
This is it.
Is this the last one?
Yep. This is the equation. I don't want this one written down.
Is that an L?
I want that one written down. That's an L.
It's one of those really.
I don't know. I don't know, but it's.
Yeah,
I
it
hate
like
it, so.
oozes ink. I'll call that the squid. That should be a name of the pen. You know how cool that would be?
Right, let's go. I want that picture.
I'm telling you, let's make it.
What kind of pen is this?
Actually, let's start it.
Let's do it. Call it off. But
Wait,
pens.
All left right now, what would you do?
Nothing.
Just do it. He can't solve
Marcus
the
all
solve.
absent.
Marcus all absent and call it
Yeah,
fairies.
but then you could just be like, no, he's just Marcus all absent.
Yeah, like if we all go in on it, I think we're good.
But still.
I don't know about Andy. Andy leaves out. I'm done. I still think it's like.
No, he'd come back in and Andy would go. If he looks down the hall and we're all just.
Just say we all went to the bathroom, and when he goes to the we're all in the bathroom.
Everybody's just standing there.
Someone else.
We'll just leave like one person in here and he's like, where did everyone go? They're like, oh, they're in the
Freshman
bathroom.
comes in the bathroom and we're all like,
Where's it?
he's coming back.
Hurry, now. We just leave.
Go, guys, you can do it.
Where did everyone go? To the bathroom.
Have you guys ever walked into the bathroom and everyone's like chanting, like,
What
No, can't stand up, Sam, can't stand up.
That's actually happened to me before. That's happened to me.
That's so
yeah, like they're
We
like,
should,
"Whoa."
have you seen how many people they can fit in a stall?
Yeah.
They fit like 30 people in a stall.
He's probably he just goes in the like the beach.
Don't be mean to Alan. Calm down.
Why is everyone always?
Stop. Why does it?
Oh, now she's playing the victim.
Oh, wow.
Allie hit me.
You called me the B word, so.
No, I didn't.
Hey,
I can hear you through next door,
Dan,
actually,
particularly you.
I got hit.
You called me the B word.
No, I didn't. I did not say
I
it.
think it was there.
I did not say it.
Why did you do that?
I didn't say it.
I didn't hear it.
They can start saying-
Exactly.
Because like,
Daxton,
I think they started saying Catholic.
remember I can hear everything on this, right? I can just go back and watch the recording.
Okay. Can't hear anything.
Yeah, I don't need that.
Would you like to go back and watch your 32 minutes on this? No. Oh my god. What's the longest video you've ever had?
48.
Was it in this class?
Yeah, you need to like have a signature ending every day.
That's a wrap.
It's your boy.
Yeah, that's a wrap.
It's your boy.
Alright, hey, my turn, let's go.
Hey,
Okay, I'm just gonna start, I'll leave it on here, but I'm gonna start talking.
I don't understand.
Hey, there's a big difference between arc measure and arc length. Alright, up until right now, all we've talked about is arc measure. Now, for this next little bit here, we're going to talk about arc length. The difference is arc measure is the degree. So it's the degree of the arc, right? It's the degree of the arc. Now, so the way I remember it, I actually had a person tell it to me this way. So, arc measure, and if you want to write this down, you can. Arc measure equals degree of arc, meaning, because it matches the central angle. Whatever the central angle is the arc measure, right? Arc measure is the degree of the arc. Arc length is how long is the arc if you were to use a ruler. So arc length is if you were to take that arc, kind of cut it, stretch it out and measure it. Okay, but I don't like using the word measure because that's in the other one. But arc length means if you were to take out this chunk of arc right here, yeah, so if it was a straight line and you stuck it next to a ruler, that'd be arc length.
Wait,
Okay?
metric?
That's why oftentimes you're going to start to see that length and length and measure are different. Any questions on why those two? Measure is what we've done up to right now. Length is this. So length, as you guys can see, there's a formula attached to it. X is the angle. All right? And you're going to start to see, I'm going to try to get my computer and tilt it up to show you guys some of the problems that you're going to see. X is the angle. You divide it by 360, then you times it by 2 pi r. Where else do we see 2 pi r?
Circumference.
Circumference, okay? So we're going to times it by 2 pi r. They'll give you the radius. That's also a telltale sign if you're using length or measure. If they ever give you the radius, you're going to use this formula. So if they say find the arc length, they'll say find the arc length, but you just, the bad thing is I see this more times than not. I'm going to get rid of, everyone good on the book?
Yeah.
Okay, I see this more times than not when I get to this, and then I immediately get a hand up. What they're going to do, here, I'm going to actually find you one. So we're going to start with arc length right now. This is one directly off your homework. So, if you want to draw it down, I would. So, what it's going to say is like, it'll say, here's a circle. Then it's going to give you a thing like this. It's going to say, here's 100, E, C, D, and that's a central angle. And F, okay. So what it says is find arc DE. It says the radius is 7. So it says the radius.
Is that an F or D?
It doesn't matter. Just yeah, this is an E. That's an F. Okay. So what they're going to say, that's the information they give to you. They say the circle below has center C and has a radius of 7 inches. Given that angle DCE is 100, find the length of arc DE. So that's the information they give to you, but too often this problem happens, and guess what the first initial response is? You go, well, this is 100, that's 100. No, that's not the case. They're not asking for the measure. They're asking for the length. Okay? So it says find the length of arc DE. Right? So the way we're going to do this is as follows. We got our formula. The formula to find the length is x over 360 times 2 pi r. Well, we know what x is. What's the measure of the angle that makes the arc we're looking for? It's 100 over 360 times 2 pi 7. And then you just go through and you plug all that into your calculator and have fun doing it. Oh, it wants it in terms of pi?
For those kind of questions.
Let me read. Oh, yeah, give exact. Okay, so it wants pi part of the answer. So this is good to see. So what it wants is it's going to want you to reduce this down to 5/18. So 5/18 times 14 pi. It's going to be like that.
Yeah, the 14 and 18 and 9, so 35 divided by 9.
Wait, I'm sorry.
Wait,
What?
what did you just
But watch, you guys all do it this way. So he basically said 2 times 7 is 14 pi, and then he went 5 times, he did it a little simpler where he went 7 over 9. But,
excuse me.
well,
What did
Not
you-
simple.
what if I just
it doesn't matter. We can just do it like this. 5 times 14 is what?
Photomath can do this.
No, it can't.
Literally half a second.
It's like 70.
So we have 70 pi over 18, which reduces to 35 pi over 9, and that would be your solution. Okay?
That's your answer?
So now look, the reason why pi is part of your answer is because the second part of this question says, give an exact answer in terms of pi. And be sure to include the correct unit in your answer. So the correct unit actually, what were we in inches? Is inches. Now the unit is whatever the radius. The radius they gave us was 7 inches. So the unit at the very end would be inches.
Wait, how did you get 35 and 9?
They're asking for the arc length.
How did you get 35 and 9?
I simplified 78 over 18.
I just divide by
It says it.
Yeah.
Yes, I just divided by 2. It says that the question, hey, listen again. The question, the circle below has center C, and its radius is 7 inches. Given that angle DCE is 100 degrees, find the length of the minor arc DE. So that's the information that they give to me to be able to get it. Here, we're going to do another. These are arc length. I know, I told you it's going to take pretty much all hour. The answer is that. Okay.
No, we can't. That's right, Janet.
Okay, here we go. It wants pi part of the answer. So here's our center. If you want to draw pictures, it's a good idea. K, M, L, N. Okay, that's the information they give to us right now. Everyone listen to this question. It says, this. Everyone listen carefully because this one gets a little bit tricky. It says the circle below has center K. and its radius is 6. So immediately, remember what I always say is draw a picture. No matter what anything I ever get, any kind of math problem using geometry, I draw a picture. And then I label it as I start to go. So it says it has a radius of 6. And then it says, given that the measure of angle LKM is 70, so we know that angle is 70. Now this is where it gets a little bit tricky. It says, find the length of the major arc. So it wants us to find the length of major arc L, N, M. So it doesn't want us to find the measure of this. It wants us to find the measure of that. It wants us to find the length of that right there. Now this is kind of an interesting question. Now, if you weren't reading carefully, you probably would have found the length of this and got the answer wrong. But it says it wants you to find the major arc L, N, M. L, N, M. So, here's our formula again. L equals x over 360 times 2 pi r. Somebody raise their hand and tell me what my x would be in this case.
290.
It is 290, but tell me why, Andy.
It's because since we're finding the other one, since a whole circle equals to 360 and we're finding the NK L1, that means it must be 70 minus 360. Which is
Okay, perfect. So listen. Hey, pay attention. Stop talking and pay attention, because I'm about ready to give out homework, and if you don't know how to do it, we got to pay attention. If this angle right here is 70, and it wants this entire arc right here, right? Well, that arc isn't 70. The measure of this angle, so we have to know what this angle is right there. That entire angle, which is 290 degrees, right? The reason why it's 290 is because this is 70, and based upon that first thing we wrote down the side of our journal, they have to add up to be 360, right? Now, this is something unique. You guys haven't seen angle measures greater than 180 till right now, right? But it's possible. You can have angle measures that are greater than 180, and they just look weird like this. Okay, but you can do it. It just looks different. But so the measure of this angle that they want is 280. So we know that the length equals 280 over 360 times 2 pi. Do I keep saying 280? So 290 over 360 times 2 pi times 6. 6 is the radius. They give us the radius, which then you have to just start simplifying it. Times 12 pi. Anybody have any questions where I got 12 from?
No.
6 times 2. Okay, and then what I would do is I would make it a little bit easier by simplifying this down to 29 over 36 times 12 pi. What's 12 times 9? 12 times 29.
I don't.
So 348 pi over 36.
I just counts out.
And that reduces to what?
29 divided by 3 pi.
29 pi divided by
Okay, 29 times 12 is 348.
I just counts it out.
So after you reduce that fraction, you get 29 pi over 3.
I don't know.
They may have you write it like this, 29 over 3 pi, like that.
They make it right like that.
They do. So they make you write it like this.
I think either way it works. It just says, well, you should write it like this. But I don't care.
I like it like that.
What a sad.
Okay, questions on that one though right now?
Let's just.
We haven't even reviewed over what we did before. I just taught the easy stuff, and then I started focusing in on the harder stuff. Okay, I want to do one more arc length. I want you guys to try it, and then I'll get to the homework.
Do we have to write this one down?
Can we just
Yeah, because you're gonna do it, so you have to write it down.
Like, two questions?
Are you trying to make a
Okay, I
record
got
for
it.
your longest video?
What am I to?
45.
I've already passed it. I think 43 was my record actually.
What a record breaker.
Here we go.
Let's get it to an hour.
Okay, we'll go to an hour.
Yes.
No, why?
If we get 12.
Here we go.
by the end,
Leave it running
we're gonna
with
take
friends.
10.
Okay, this is the information they give to us. That's 170. R, P, Q. And the radius is 4.
Oh, my circle.
It wants us to find the minor arc QR. Okay, so it wants us to find the minor arc QR.
Honestly, the mark, do you ever write your section like as an R or something?
No.
I definitely do. Like, I just am so used to like, just having something.
Mr. Glazer, I think I made a perfect circle.
Really?
I'm not even kidding.
Jackson,
It's actually very easy to simplify them.
Pretty good.
Until they get you like 176.
Yeah, it's just.
But they won't give you that for the alpha sign. I've already seen this 28,000 of these.
there's the formula if you can't remember it.
They give you like 5 or something. They make it to you just gotta change your mindset. Geometry. You can't think so straightforwardly. No, that one. Yeah, it's all fine. You have to find the circumference first. It's all fine.
When you said we were on our own,
Yeah.
4 inches? What?
Carson, you need to go back out to the hall. Okay. First off, what's the angle we're looking at? Would the angle we want be 170 or 190? 170. Why, Max? It's looking for the minor arc. If it wants a minor arc, it's going to be less than 180. If it's looking for the major arc, it's going to be greater than 180, whatever our x is. So this is how you set it up, if in case you're even struggling with that. What's our radius? Oh, 170, sorry. Okay, there's our formula in case you're struggling. Go for it. When you're done with it, hop on your homework. It's open.
Can you just do 17 or
36. Yep, I immediately do it.
like, just like,
Yep.
wait, what's the inscribed name?
Huh?
Inscribed.
Why is that on there?
I don't know, but it has.
That's not even in this
I know,
section.
it's not in the section, but it has.
Give me a second.
I'm doing this so wrong, I'm not even gonna write it down.
Okay, so look up here. Hey, look up here. So 170 is our angle. 4 is our radius. We do that. What's 17 times 8?
136.
136 pi over 36, which reduces to what? 34 over 9? 34 over 9 pi. Who got it right? 34 over 9.
Well, honestly,
I didn't write it down.
Okay. Hey, look, your homework's there, but there's a question on it you guys don't know. And I don't know why this is in this section. That's something new Alex did. Hey, look up here real quick. No, it's part of the question. Look up here. Hustle. Everyone needs to look up here.
It's an angle that goes from the 1 point, so it's not.
Okay, look up here. Everyone look at this. Look at this circle with me. Okay. Central angles are angles we've been talking about, right? Angles that start off in the center. So this angle would be A, B, C, or CBA, right? An inscribed angle is an angle that has its vertex on the edge of the circle. So you're going to, well, you don't need to because the next section is all about inscribed angles. I don't know why I threw it in here. So an inscribed angle is an angle that's vertex is on the edge of the circle like this. And inscribed angles can look as funny as you want them to. Like I've seen them look like this before. That's an inscribed angle. See that? Because the vertex is here and the endpoints are on the edges. Inscribed, I think, tomorrow. I might go over this more though.
Wait, what's the central angle?
Central angles are center angles.
Oh, those, yeah.
And then I've seen inscribed angles as funny. I've actually seen inscribed angles like this. Like that.
Hey,
Oh, I did give you those questions.
why are you saying that Alex is wrong?
You just gotta restart your computer.
Like the whole.
Then it gives you like a whole rectangle.
Or maybe refresh it. I can't remember what people do.
Wait, can we make this exit? Would it be YSW or YSD?
I just 170 over 360. I just reduced it, canceled out the zeros.
Yep, another one.
Oh, I know, 50.
There can be an adjustment or something.
How, bro?
What's up? Scores?
Yeah, chapter 7 review is 100. I think that's my only one.
That's it.
And then my mom wrote this for the first day of school.
First day, Judas, Sam.
Yeah, I kept forgetting to write it.
Okay, you're good.
I was actually
Throw it away.
sick, same thing I have now. So.
Really?
It's a major angle.
I just still have to Mr. Laser, can you help me for a
You can
second?
just go
Yep.
HDMI. You can skip some,
Hey, where are you going?
Oh,
Of course I do.
I figured today reading that might be inappropriate for a teacher to have on their wall.
Oh,
I didn't use it.
Hey, I gotta stop this in 52 minutes. God.
That's a record.
Hey,
It's
Ryan,
impossible.
I can go.
You gotta write on that one.
Don't